Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 3, Learning Target 1. Today we are kicking off Unit 3 by talking about finding the greatest common factor, or in other words, GCF, as we abbreviate it most of the time. So when we find the greatest common factor of two numbers, we are looking for the largest number that divides evenly or wholly into both numbers. So if we're looking at two things, we want to see what number goes into both of those. That's what GCF is. It's the greatest common factor. So if we're looking at something like 6 and 9, factors of 6, the factors of 6 are 1, 2, 3, and 6. Those are the numbers that when you multiply them together, they get to 6. For example, 1 times 6 is 6, and 2 times 3 is 6. Okay, so that means that 6 divides by those four numbers wholly and leaves you with a whole number. The factors of 9 would be 1, 3, and 9, because 1 times 9 is 9, and 3 times itself is 9. So if I look for the GCF, greatest common factor, my greatest common factor of 6 and 9 is 3, because that's the largest number that goes into both 6 and 9. Let's talk about 8 and 12. If I think about the factors of 8, the factors of 8 are 1, 2, 4, and 8, because 1 times 8 gives me 8, and 2 times 4 gives me 8. If I think about the factors of 12, I have 1, 2, 3, 4, 6, and 12. There's quite a few factors of 12. And you can kind of think of them in terms of pairs, like I have with those yellow arrows drawn together. So 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So all of those numbers are factors of 12 because they're numbers that when you multiply them together, they give you 12. So if I look at those two lists together, again, I want the GCF. So I have 1, 2, 4, and 8, 1, 2, 3, 4, 6, and 12. I see that 1 is in common. 1 is always going to be in common, by the way. That's always going to be a common factor. And sometimes that's your greatest common factor, but not always. Sometimes you can have one that's bigger. You also see 2. 2 is a common factor, but then you see 4. And 4 is your greatest common factor. So that gets you the G of the GCF. So my GCF between 8 and 12 is 4. Let's talk about 5 and 10. Factors of 5 are just 1 and 5. Those are the only two things that multiply together to give me 5. Factors of 10, I have 1, 2, 5, and 10, because 1 times 10 gives me 10, and 2 times 5 gives me 10. So if I look at the GCF is 5. If I look at 2 and 7, factors of 2 are simply 1 and 2. That's the only pair of numbers that multiplies to give me 2. If I look at the 7, factors of 7 are 1 and 7. Those are the only two numbers that give me multiply to give me 7. So my GCF here's an instance where my GCF is 1. These two numbers have no other factor in common except 1. Now, we can also find the GCF of two variables. So when we are looking at the GCF of two variables, it's the variable, we look at the variables they have in common, and then the one with the lowest exponent is your GCF. So you kind of have to think of the exponent as the number of factors of that variable that are in that term. So let's just talk about it in terms of x to the third. X to the third is the same thing as x times x times x. X to the fifth is the same thing as x times x times x times x times x. Okay, so I have 3 factors of x, and then I have 5 factors of x. And I need to see how many factors do they have in common, because again, I'm looking for greatest common factor. So the things that they have in common, I see 1 factor of x, I see another factor of x, and I see another factor of x. They have 3 factors of x in common. Now, I can't go to the 4th or the 5th because this one over here on the left doesn't have 4 and 5. But both of them have 3. So my GCF here is x raised to the 3rd power, which also coincidentally happens to be the variable with the lower exponent. If I look at the y's over here in number 6, I have y to the second, which is y times y, and y to the seventh, which is y times y, y times y times y, 6, 5, 6, 7. Did I get them all? 1, 2, 3, 4, 5, 6, 7. Yep, I got them. So if I look at what they have in common, this one on the left has 2 factors of y. This one on the left has 7. So that means that 2 of them are in common, but then it has 5 more that are extra. So the 2 that are in common means that my GCF is y to the second, which again is the same thing as the variable raised to the lower power. You can see that y to the second, y to the seventh, y to the second is your GCF. So if I use that theory here, now I'm going to find the GCF of both numbers and variables. I like to start with the numbers because sometimes I think it's even harder to figure out the number part of this and easier to figure out the variables. So I do the harder part first and get it over with. So factors of 10 are 1, 2, 5, and 10. Factors of 15 are 1, 3, 5, and 15. So my GCF is 5. And then if I look at my variables, I've got x to the second and x to the third. So the one with the lower power is going to be my GCF. Now put those two together. GCF. I'm going to have 5x squared. That's the GCF of these two whole terms together. If I look at 3x and 5x squared, remember that this is 3x to the first. The only factors of 3 are 1 and 3. The only factors of 5 are 1 and 5. So the only common factor that I have here is a 1. And then if I look at my variables, the lower power is the power of 1. So my GCF is 1x to the first. Or, in other words, you could just write that as a GCF of x. Having a coefficient of 1 does not make any difference, and having an exponent of 1 does not make any difference. So my GCF of those two terms is 1. Okay, so now steps to finding the greatest common factor. If you're a step-by-step person and you like following those, here's where I talked about just the two that we were looking at. So find the largest number that divides into each coefficient. That's the number part. Then find the smallest exponent of the variable. Okay, then we're going to go ahead and we're going to divide out the GCF. Okay, so that's the variables, the letters. Then we're going to divide out that GCF and we're going to write the new polynomial behind it. So this is actually, I kind of want you to change your directions here. This is not steps to finding the GCF. This is steps to factoring out the GCF. Okay, so steps to factoring out the GCF. That's what we're going to do now. Instead of just identifying it, which was what we've been doing so far, now we're going to actually factor it out. Okay, so factor out. Again, I want you to change your steps here. This is not find the GCF because we've already been doing that. This is factor out the GCF. Okay, so if I'm factoring out the GCF, that means I need to find... First of all, find what the GCF is. My factors of 12 are 1, 2, 3, 4, 6, and 12. My factors of 16 are 1, 2, 4, 8, and 16. So my GCF of those two looks like 4. Okay. And then the variable is going to be a to the first power. Okay, so that's the first thing that you could recognize is the GCF is 4a to the first. But now I'm going to actually go through the steps of dividing that out. So I have 12a squared plus 16a. I'm going to go ahead and divide out 4a to the first. That means now this 4a to the first is going to come out front of these two things. So I have 4a to the first, and then the leftovers, that's what I like to call them. The leftovers are what's going to be left behind. So I'm going to divide 12 by 4, and that gives me 3. And then a squared divided by a gives me a. And 16a over 4a, 16 divided by 4 is 4. And a divided by a, those a's are going to cancel. So what I have left inside is the 3a plus 4. And on the outside is my GCF. So this is my GCF. And this is my, what I like to call the leftovers. This is what we call factored form. Okay, that's our factored form of our expression. So what we're doing here is we're essentially taking apart the multiplication. This multiplication was distributed, this 4a was distributed inside the parentheses, and it led me to this polynomial up here. But now I'm taking apart that multiplication and undoing it to put it back in its original factored form. Okay, so let's take a look at the next one. Now I have 3 terms here. So I first need to start by finding the GCF of those 3 terms. I have a 14, a 6, and a 4. Now the only thing that I'm going to be able to take out of those is a 2. That's the only thing that all 3 of those have in common. So I'm going to divide out a 2. I can also divide out that variable to the lowest power, which in this case is an r to the first. So I'm going to take 2r out of each of those. This thing right here is the GCF. Okay, so that GCF is going to be brought out to the front. So 2r. Then actually do the division. See what's left over. 14 divided by 2 is 7. R to the third divided by r is r squared. If you have 3 r's and you take one of them away, you have 2 left, so r squared. That's the first term. Then the middle term, 6 divided by 2 is 3. R squared divided by r is r. 2 r's on top, divide out one of them, you're left with 1. Then the last term, there's a minus there, so be careful. 4 divided by 2 is 2, and r divided by r, that's going to cancel out. So I'm left with, on the inside, 7r squared plus 3r minus 2. That's what I like to call the leftovers. You'll hear me refer to that. And this thing out front is the GCF. And writing my answer like this is what we call factored form. So if you're writing these things out in factored form, that's what it looks like. Now, our brains are going to tell us, hey, we need to distribute that 2r back in. But that's not the point here. The point is to take apart multiplication. There are reasons we're going to need to take apart multiplication. And that's what we're teaching you in this factoring unit. Unit 3 is all about factoring. So taking apart the multiplication is going to be important for us as we move forward into other units. Okay, so again, I'm going to factor out the GCF. I'm not just finding the GCF, I'm factoring out the GCF. So the first thing that I want to do is look for what that GCF is. Now, I see that I have a 5 and a 30, which means I can divide out a 5. Now, be careful with your variables. I have an x here and a y there. They don't have common variables. There's nothing in common between those 2 variable parts. So I don't have a variable part of my GCF. All I'm going to take out is that 5. So the 5 is going to be the only thing that comes out front. So when I divide out the 5, here's what I have left. 5 divided by 5 goes away, and I'm left with just x by itself. In the second term, 30 divided by 5 is 6, and I also have a y. Okay. The other way that you can tell that you're in factored form is there should be nothing in common in the leftovers. The leftovers should have nothing in common between them. So there shouldn't be any common factors, and there shouldn't be any common variables that you could take out of either of those terms. From the leftovers, I mean. All right, let's do number 12. In number 12, the number parts are a 12, a 3, and a 9. So what can I take out of 12, 3, and 9? I can divide out a 3. 3 is what's in common there. Now, when I look at the variable, I have an x to the second, an x to the first, and no x's. Okay? There's no x there. So again, this is another place where not all terms have a common variable part. Do not take out an x. You can't take out an x here because there's no x with that 9. So your x's are going to remain untouched. The 3 is going to be the thing that we bring out front. So 3 is my GCF between all of those terms. Then 12 divided by 3 gives me 4. My x squared is untouched. 3 divided by 3 gives me 1. My x is untouched. And 9 divided by 3 gives me 3, and there are no x's there. So that is the factored form of that expression. The GCF was 3. That was the only thing I could take out. Okay, 2 more of these. Factor out the GCF. I'm not sure what your notes say, but they should say factor out the GCF instead of just find the GCF. Okay, so here are my new number parts. 4, 12, negative 8. So I can divide out a 4 from all of those. That's the GCF of the number part. Then of the variables, I have x to the third, x squared, and x to the first. I'm going to take out 1x. My lowest power is that one. So this one I can take an x out. So that 4x is my GCF. It's going to come out front. So when I do that, 4 divided by 4 goes away. X to the third over x is x squared. In the middle term, 12 divided by 4 becomes 3, and x squared over x is just 1x left over. I started with 2. I divide out 1, so I have 1 left over. And then in the last term, 8 divided by 4 is 2, and it's truly a negative 2 because of that minus in front. And then x over x goes away. When I look at my leftovers, I have a 1, a 3, and a 2. Those don't have any numbers in common. I have an x squared, an x, but no x there, so those don't have any in common. So that is my factored form. And don't forget, by the way, to write your GCF out front of those parentheses. Your GCF is still part of the expression. It's just out front now instead of factored into the expression. Okay, last one. So the number parts that I have here are 5, 15, and 20. So I can divide out a 5 from all of those. Then the variable parts, x to the 4, x to the third, x to the second, which means my lowest power is x squared. I can take out an x squared. Okay, so now let's actually take that GCF and put it out front of and do the division. So it's going to be out, oops, not 4, hello. It's going to be out front of our remaining polynomials. So I have a 5x squared for the GCF. Now do the division. 5 divided by 5 goes away. X to the fourth over x squared is x squared. In the middle term, 15 divided by 5 is 3. That gives me 3 left over. X to the third over x squared leaves me with 1x. And then in the last term, 20 divided by 5 is 4. And x squared over x goes away. So my leftovers are x squared minus 3x plus 4. And I have a GCF of 5x squared out front. All right, that takes us to the end of our notes for right now for this lesson. Thanks for tuning in, and I will catch you next time.